This video is about the C declaration syntax. The C declaration syntax is more than a bit strange, but its rules allow you to create a declaration for any type you could use in C. The basic rule behind the C declaration syntax is called declaration mimics use. The idea is that we form the declaration statement by mimicking the syntax we will later use to use the variable. Suppose we have a variable f, and we subscript it with possibilities 0 to 10 semi-inclusive, and we dereference it, and we call it, in other words it was a function, and then we get an int. Well, I guess this means that it must have been an array of 10 pointers to functions returning int. That's the idea. This last line is a declaration, not a statement, not an expression. But it's a declaration which mimics the eventual use of the variable f. The reason it means that f is being declared as an array of 10 pointers to functions returning int is because when we eventually use it, if we use it like this, that would only be appropriate if f did have this type. Sometimes we build up more complex declarations like this in stages with typed f. But the key to understanding even simpler declarations, like int star f of 10, is that declaration mimics use. Here we subscript it and then dereference it and get an int, therefore it must have been an array of 10 pointers to int. Similarly to declarations, we also want to be able to create a cast to any type which we can use in C. The syntax for a cast is derived from the syntax from the corresponding declaration. What you do is make a declaration, remove the variable, and put parentheses around everything. For example, to cast to int, we look at a declaration, we remove the variable, and put parentheses around the whole thing. So the way to write a cast to int is left parenthesis int right parenthesis, but that's easy. This declares variable p as type pointer to char. To make it into a cast, we remove the variable and put parentheses around the whole thing. So to cast a pointer to char, we use left parenthesis, char, star, right parenthesis. Slightly more complex is a pointer to char. To make it into a cast, we remove the variable and put parentheses around the whole thing. So this last on the right is a cast to pointer to char. For a more complicated cast, let's look at a declaration of a pointer to a function returning a pointer to char. You see why this is such a declaration. P is dereferenced and then called, so it must be a pointer to function, and the result is dereferenced and then is a char. In other words, the result was a pointer to char. The usual operator precedence rules apply here, and all of those parentheses are needed. To make this into a cast, we remove the variable and put parentheses around the whole thing. Note that the parentheses around that asterisk are crucial. This shows that it comes from the declaration on the left. It's probably more obvious why those parentheses are relevant in the declaration on the left, but actually those parentheses in the cast correspond exactly and are equally relevant in changing the meaning of the cast as the original parentheses are in changing the meaning of the declaration. There's a very useful program called Deckle which packs and unpacks declarations and casts. It's particularly useful for checking that your declarations actually mean what you think they mean, but it can also be used to generate declarations. I want to emphasize the mimics. The declaration mimics the subsequent use of that variable. It is not the same. The asterisk means basically completely different things in the declaration int star p and in the statement x is assigned star p, assuming suitable interim operations. In int star p, the asterisk indicates that we are defining a variable of type pointer to int. The reason it indicates this is because of the declaration mimics use rule. In x is assigned star p, the asterisk is an operator. It performs a computation, which is that it follows the pointer value of the variable p, reaching the int which is pointed to. This is an operation.